Alright, let's look at the homework 7.9-8.1, problem number 3. Alright, so we want to use a double integral to find the volume of the solid bounded by these guys in the first octant. Alright, so let's sketch the region on the xy plane. Since this is bounded by x squared plus y squared equals 49, so this is the cylinder. Circular cylinder with radius 7. Alright, so the region on the xy plane is going to look like this. X axis, and here's the y axis. Alright, so this is basically a cylinder with radius 7, so you can draw a circle with the radius 7. So it's going to be 7 right here, and 7 right there, right? Then it's gonna look like this. So it's a quarter circle, right? So this is the region that we want to integrate the surface over. All right, let's set up a double integral. So the volume V that we're looking for is going to be a double integral of so this guy z equals x plus y, so you have x plus y, and I'll probably do it with respect to y first, then with respect to x, right? So this guy has the equation x squared plus y squared is equal to 49, right? Then if you solve that for y, you can see that it's y is equal to square root of 49 minus x squared. All right, so let's fix x and say x is here. Then we look at the line segment and we want to determine where this line segment starts here and it ends here. Right here, y value is 0 since it's right on the x-axis, right? Then here, this is right on the circle, which has an equation here. So y equals square root of 49 minus x squared would be where it ends, right? So the lower limit is now we know that the y equals 0. Then upper limit is going to be y equals square root of 49 minus x squared, right? So in order to cover the entire quarter circle, we need to start from x equals 0, which is right here. So x equals 0. Then keep on increasing the x value until it covers the entire quarter disk. So the ending point would be x equals 7. Right? So this is going to be lower limit is x equals 0. Upper limit is x equals 7. Right? Let's evaluate. All right, so let's do the inside integral first. So we're going to leave the outside one as it is. So 0 to 7. Right? So antiderivative of x plus y with respect to y would be, right, x is just a constant, so it's going to be xy plus antiderivative of y would be y squared over 2. Then you're going from y equals 0 to square root of 49 minus x squared. Then you have dx. All right. So if you plug in the top one for y, you're going to get integral from 0 to 7. Then you have x, and y is now square root of 49 minus x squared, right? I'm going to split this integral into two so that we can work on them separately, right? Then if you put, so it's going to be plus integral from 0 to 7, right? If you plug it in here, so it gets squared, so square root is going to be gone. So it's a 49 minus x squared over 2 and dx. Right, but when you plug in 0 for y, it's all 0 anyway, so we don't have to do anything. So this is all we have, right? So I'm going to call this guy integral 1, and I call this guy integral 2. Right, so let's evaluate I1. Alright, so I'm going to use a substitution. Let u be 49 minus x squared, right? Then you can take the derivative of u with respect to x is equal to negative 2x, and take the reciprocal of both sides so that dx goes on top, and it's going to be 1 over negative 2x. Then multiply both sides by du, so dx is equal to du over negative 2x. All right. Then also, let's see, x goes from 0 to 7. So x goes from 0, x goes from 0 to 7. So in this case, u is going to go from, if you plug in 0, it's 49. And if you plug in 7, 49 minus 7 squared is 0. All right. So this is going to go from, integral is from 49 to 0. Then you have x is still there, right? Then square root of, we decided to call this guy u. That's our substitution. So it's a square root of u, right? And the dx is right here. Dx is the same thing as du over negative 2x. So it's a du over negative 2x. Right? Then we can cancel x on top and x on the bottom. And there's a negative sign. I'm going to use this to switch the lower limit and the upper limit. Right, so that it looks a little bit better. Right, so what you get is, right, so 1/2 is just a constant, put it outside. Right, so the integral is from 0 to 49, and I don't like square roots, so I'm going to write it as a u to the 1/2 power, then with respect to u. Right, then we can just use the power rule. So it's going to be 1/2 is still there. Right, antiderivative of u to the 1/2 power is u to the, add 1 to the power, 3/2. Divide by 3/2 is multiplied by 2/3. And then you're going from 0 to 49. All right. Then 2 on top and 2 on the bottom cancel out. And if you plug in 7, so it's a 1/3. Right? If you plug in 49, so it's a 1/2 power is square root. The square root of 49 is 7, and a 7 cubed. So what's 7 cubed? 7 times 7 is 49 times 7. 63, 7 times 9, 63. 28, so 34, right? So it's going to be 343. So maybe I should write it, let's see. So this comes out to be 343 over 3. And if you plug in 0, it's 0 anyway, so this is that. All right, so that's I1. All right, let's compute the I2. So I2 is going to be, all right, so 1/2 is just a constant. I'll just put it outside. All right, antiderivative of 49 is 49x. Antiderivative of negative x squared would be negative x cubed over 3, right? Then you're going from, in this case, 0 to 7, right? So this is going to be, all right, 1/2 is here, and plug in 7, so 49 times 7, we just did that one, 343, and a minus, right? You have 343, because 7 cubed over 3, right? So this is going to be, let's see, so 1/2. All right, so this is going to be 3 times 343 over 3 minus 343 over 3. So it's a 2 times 343 over 3, then divide by 2. So this is really, actually, 343 over 3. All right, so then if you want to find the volume V, so we know that the V is going to be equal to, right, so it's just I1 plus I2, which is 343 over 3 plus another 343 over 3, right, which is going to be 686 over 3, right? So that's the volume of the solid that we're looking at. All right, so let's double check. All right, the answer we got was, say fraction, 686 over 3. All right, let's submit for testing. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.